902, providing a place where you can learn and enjoy math and chess.
Engineers are designing a new motorcycle. They measure the fuel level after driving the motorcycle long distances. Each point of the graph represents a fuel level in the gallons of the motorcycle has traveled in a particular distance in miles. What does the y-intercept mean in this problem? So there's the y-axis, so it's that order pair, which would be 5, 0. So 5 represents the x. Sorry, wrote that wrong. Hello. 0, 5. X represents the miles traveled, so miles. And then the Y represents the gas level. So before you've traveled 0 miles, then you should have 5 gallons of gas there. So which one is that? The y-intercept measures the miles traveled when the gas level is 5. That is choice C. C. Because our gas level is 5, and then traveled as x would be 0. Okay, let's try now the next one. Okay, question number 5. Which of the residual plots indicates that a linear regression will be appropriate for the data it represents? So remember, residual plots, when it is scattered, it is good to use whatever we're looking for. In this case, we're looking for it as a linear. So which one is more scattered? This is a patterned, right? So I'm not going to use that one. No, same thing, patterned. This one's scattered, so this one is good. I'm going to use graph A for number 5. So we're going to be using linear regression equation. Best represents the line of best fit. That means our regression line, least squares regression line for the data if x represents the number of years since 2000. Okay, so let's punch in those numbers. I'm going to go stat, edit, go to the top of my list, press clear, then enter. Do that for both of your lists. And although it says number of years since 2000, yeah, let's do blah, 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 blah. Let's go back here. Let's just try year since 2000. So this would be 0. 0 plus 2000 gives me 2000. And then this next one would be 1, because 1 plus 2000 gives you 2001, right? Does this make sense? 2 plus 2000 gives you 2002. So that's years since 2002, and this would be a 3. Okay, so let's put that 0, 1, 2, 3. 0, 1, 2, 3. And then I have 40,000, 42,000, 46,000, and 44,500. Okay, so I'm going to press stat next to the left key, calc, linreg 5. And it's telling me there, so second 1, comma, second 2. And remember, good habits is just storing it into yvars, so vars next to the down, yvars, and then just click that. Okay, dimensions mismatch. What does that mean? If you go back to your list, you may have saw it. I did not press enter on the last one, which means that my lists are mismatched. One's longer than the other. Okay, there it is. Try it again. And bars, y bars. Okay, remember if your r and r squared don't pop up, then you have to do diagnostic on. So a in my formula is in front of x, so that is my slope. So the only one that has 1750x plus 40,500 would be choice C. Age of parents. Consider this scatter plot. So I have the mother's age and the father's age. Select all the statements that describe the scatter plot. Select all the statements, so it can be more than one. I'm going to put a line in here, what I think is the best fit. Does it show positive? Yes. Is it a negative correlation? No, because that would be this way, right? No correlation, no. Okay, strong and moderate. I generally think that most of these are close to the line. Pretty strong, so answers are A and D. B, the answer is A. Question number 11. Miss Brubaker is a guidance counselor at Apple Grove High School. She is giving a presentation to the freshman class about the importance of studying and getting good grades. In her talk, she likes to show the freshman data she has collected about some students who went to the high school and their progress in college. The data for the 12 students and their GPAs, as well as their first year college GPA, the table shows the data she has collected. Okay, what is the explanatory variable? The explanatory variable explains, helps explain the response. Explains this. Well, here, not because it's showing to us, but the high school GPA explains your college GPA. So, age A is going to be high school GPA. And what is the response? That would be college GPA. Okay, construct a scatter plot using data on your own graph paper. I mean, you can just put that in and get it to your calculator. Let me do that. See if this thing doesn't crash on me. If it crashes on me, I might not throw away. I'm tempted to throw this thing. 2.22. Just putting in all the numbers. It's Christmas and my calculator on my tablet's not working. The very next day, you did it again. This Christmas, You knew it's something done special. 288. Okay, let's go up to list 2, and this is your college GPAs. 2.35. 2.8, 388, 3.4, 2.95, 310, 355, 392, 340, 350, 352, and 2.90. Okay, I'm just going to go press second y equals to get a graph. Click that. L1, L2, yes, and then press graph. Okay, ignore that green one because I didn't actually create an equation. If you wanted to, we could do that. Stat, calc, linreg, list 1, comma, list 2, comma, 1, comma, vars, y vars. Okay. And then when you press graph, it should be there. Boom. Oh, yeah. Okay, there's my graph. So what do you guys think? Describe it, suds. Shape, linear. Unusuals, no. Direction, positive. Strength, strong. That's what I would describe it with. So, is there association? Yeah, I think it's C. I think it is linear. And you can, another way of double checking that is our correlation was strong and the coefficient of determination was also very strong, 0.86. So yes. Okay. D, is there a positive or negative association? So I'm going to say positive. Which order pair for the student with the highest, write the order pair for the student with the highest GPA, high school GPA. So I'm looking at this list here and 342, 3438. So I see 3.80, comma 3.92. That's the order pair. Okay. E, the x coordinates are the high school, and then the y coordinates are the college GPA. So D, blah, 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 blah. That one's worth 7 points. Okay, number 12, I think the last one. A linear model shows that relationship between the grocery item numbers, number of grocery items, I don't know, 0 to 20, purchase, and the total cost, money, $0, $100, has a correlation coefficient of 0.97. So got to be strong, right? Okay. Which statement about the variables is true? Purchasing more items causes a higher cost of grocery bill. Okay, this is the red flag problem. No. Although there is a strong correlation or association, the association is not causation. This does not cause that, okay? We can present a strong relationship, right, with the correlation coefficient and all those things, but that's the red flag word. Don't use that one, okay? All right. A grocery bill has a higher cost than, so high, then the more items must have been purchased. That's a strong statement saying if then it must be this. And I would say that this one is false. Because you might go to the grocery store like I did around Thanksgiving and you want to buy steaks and they were like crazy high. So just because you buy a lot of items doesn't, or you buy lobster, it's not the case. Okay, C, there is no relationship between the number of items purchased and the cost. No, we know that because we have R equals 0.97. And D, there is a strong relationship, I like the word strong, between the number of items purchased and the total cost of a grocery bill. Yeah, that's it. Number 12 is D. The doctor randomly selected patients from different age groups. He compared the relationship between X and the age in years and Y. The height is in inches for each patient. Scatter plot shows the doctor's data below. Okay. So, you know, if you put your kids in and they track their heights and a bunch of different ages and heights, Philip down here, is a 15-year-old patient whose height is 75.75. So let's go find Philip. I have age 15 and around 75 is there. So I'm going to say that Philip is this order pair right here. Okay, so based on the line of best fit for the scatter plot, which is the approximate difference? So this would be a subtraction of Philip's height. So I'm going to put a word here, actual, and the expected or predicted. So which has these two words here? And you should be thinking of residuals. That's actually a formula for residuals. So they're not telling us this problem, but that's what they're actually asking us. What is the approximate difference? So if you go up here and we zoom in, now here is 75.5, and he's actually supposed to be on the line. Let me use a different color. He's supposed to be on the line here, and let's just say that number is like, I don't know, 68, 67, okay? So that would be a difference of 75.5 minus the 68. That gives me around 7.5. And 7.5 is closest to which one? 8. So number 4, the answer is 8. Philip is actually 8 inches taller than the expected. Does that make sense? Because it's above. Okay, question number 7. I don't even know what that is. An ornithologist wants to look at the relationship between the breadth of a peregrine falcon egg and the mass of the falcon chicks that hatch from them. The data show a linear pattern with a summary statistics below. Linear pattern, so that is an least squares regression line, and then summary statistics. So this is the one where you have two formulas, because I allow you to, and I'm just going to pull out my formula sheet. And so I'm going to copy down what I have from my formula sheet. So I have y hat equals a plus bx, okay? Now, if you chose to use b plus ax, it doesn't really matter. It's just you need to know that this one has no x. So this one is my y-intercept. And for the y-intercept, the formula is a minus equals y bar minus b times x bar. Now, if you notice that this formula has a b value, so we're going to have to calculate the b first. So the one in front of x, this is called our slope, and the slope formula with summary statistics is b equals r times sy over sx, the standard deviation. Okay, let's go ahead and find these. So my correlation is here. The standard deviation of y is here. And the last one, we will use red. Sx is here. Let's put those in. B equals 0.95. This is a fraction, so 4.6. And red is 2.3. And I'm just going to make this a longer fraction. I'm going to multiply the top and the bottom, so let's go ahead and do that. Let me show you, so I'm going to take a picture of my work. I'm at the home screen, so I'm going to press 0.95 times 4.6 divided by 2.3. And we have an answer of 1.9. Okay, so this value here, B, is going to go right there. And then let's get some other ones. Our average for the y's is going to go here, and our x bar of 41 is going to go there. Okay, let's fill that in. So y bar is 33.6 minus a b value, which we just found, which is 1.9 in purple there, and an x bar that is 41. Okay, remember I'm going to do PEMDAS here, so I'm going to multiply those two numbers. Okay, let me take a picture so you can actually see the calculations I'm putting into my calculator. I think it's super helpful. So I have 33.6. I always like to use extra parentheses. In this case, you can use the subtraction or minus sign. 1.9 times 41. And that gives you negative 44.3. Negative 44. Negative 44.3. Okay. So to put that all back together, I have y bar equals my a value, which is negative 44.3, and then my b value, which is a positive 1.9x. Or you can also have, if you just change it around, you can have 1.9x minus 44.3. Okay, so let me just highlight that. Any of those values could be your answer. Okay, now it told me to round my entries to the nearest tenth, but either's would work. Okay, let's go on to the next one. Number 8. The table shows the fuel efficiencies of a vehicle at different speeds. Use a quadratic regression on a featured on a graphing calculator. Write a quadratic function that models the data. Round A, B, and C to the nearest hundredth. So hundredth is 2 decimal places, but you have to look at the third one. Use your model to approximate the miles per gallon when the car travels 70 miles per hour. So let's go ahead and put that into our calculator. Left arrow, stat, edit. Go up there, press clear, enter, and then looks like it's just counting by 5s, 40, 45, 50, 55, and then 24.1, 26, 27.5, 29.4, 30.7, 31.2, and 29.9. Okay, I see that my lists match. Okay, so I'm going to go stat, calc, and number 6, quadratic reg. Where do I have them? List 1, list 2, which is number 2, second 2, comma 1, comma vars, go to y vars, and then click y1. All right, take a picture of this. Okay, let's go back. Okay, so they want us to round to the nearest hundredth. So this one's going to be negative 0.01. B is 1.07. Because I looked at the third one, It's higher than 5, so we round the 6 up to a 7. C value 3.69. Okay, y here is just basically y hat. So ax squared plus bx plus c. So I'm just going to put all those numbers in. Negative 0.01 x squared plus 1.07 x plus 3.69. And you can verify that's the formula by, because we're going to have to approximate miles per gallon. So question is this an X or an Y? It's telling you approximate the miles per gallon at 70 miles per an hour. So the question, is that going to be an X or a Y? It's telling you miles per hour, mph, so you're going to put in 70 for X. Now I can use my calculator. I can go to top left, y equals, it's already in there. Now to be careful, I have to be careful because we rounded. So let me see, can we change these numbers? Yeah. I'm gonna, well, let's just see what happens. Let's see how close we can get. Okay, so here I'm gonna do a second table. Table's above the up arrow, second table set. And you want to make sure it's on ask. Doesn't matter where the table start is. It doesn't matter even what the change of the table or how it moves the numbers up and down. So just press table. And then we wanted 70 miles per hour. So press 70 and I get this number 26.59. Let's see if that's good enough. That's using our calculator, 26.59. And question number 8. Ooh. That number is off. Okay, let's see if we can do better by putting it in here. 70 squared plus 1.07 times 70 plus 3.69. So I'm going to square it first. You could try putting all that into the calculator. Let's just try it. You can, I know it works. So let me show you. Remember, because what's the difference between that number and the answer I think it is that we're rounding. Squared plus 1.07. So for every x value, there's also a function notation, but again, we rounded here. All right. 29.59. That was the answer I was looking for. So 29. Okay, if we rounded answer, rounded 29.59, and this one is if you just use the quadratic regression, not rounding. So this would have been the best answer, and I'm noting that, so as I grade, I'm gonna have to grade it by hand for students on question number 8.
Want to go from hating to loving math? Subscribe to David Ng's channel to learn new ways to do math.